In 7.6, we're going to add 5 new formulas. This is on page 600 and we're going to have these 654 at the top of the page. They're called the double angle identities. And we're going to take the time to prove one of them. We're going to prove that sine of 2 theta equals 2 sine theta cos theta. And this is a very tough proof initially because our main strategy for proofs was change everything to sine and cosine. That's already done. Also in our main strategy is to get both sides simplified like a single fraction if you've got lots of fractions. These are both over 1. They're both already single fractions. Second strategy said if you have something squared, then maybe you can use your Pythagorean identities. Well, there's nothing squared in this one. Then our third strategy was build the other side. Can you get the denominators the same? But if we had denominators here, they're both over 1. That's technically the same already. So we're stuck again. All 3 of our main strategies don't seem to work. And for this one, the strategy that's going to be the breakthrough, you have to go back years and use a strategy and use some mathematics that some of you might have already known before you went to kindergarten. That's how complicated this proof is. We have to go back to pre-kindergarten. What are some of the very first math things you learned? Addition? What kind of addition did you learn? What do you think the first addition thing you learned was? 1 plus 1 equals 2. That's the key to this proof. If you know that 1 plus 1 equals 2, you could rewrite this side and say instead of having 2 thetas, I have 1 theta plus 1 theta. And it seems kind of like it's such easy math that you're like, why would I ever want to undo adding 1 plus 1 equals 2? But now, the left-hand side, we could use an alpha plus beta formula. And if alpha is theta and beta is theta,
the theta in front of the brackets, is that supposed to be?
oh, that's not supposed to be there. Thank you. It's just supposed to be sine. Thank you. Theta plus theta. Yeah. Alpha plus beta formula. And so, using our formula, well, that would be sine theta cos theta plus cos theta sine theta. Because it's sine alpha cos beta plus cos alpha sine beta. And then you get to use your like terms and your grade, well, pre-kindergarten math again. If I have one of these and I add another one of those, I'm going to end up having 2 of those. Now, you'll never have to prove this one. But the proof is quite simple. And that means now we have these 3 new formulas, which are called the double angle identities. We have 1 for sine. We have 3 different ones for cos 2 theta. And the reason we have 3 different ones for cos 2 theta is if you started with one of them, cos 2 theta equals cos squared minus sine squared, you could replace the sine squared with 1 minus cos squared. And then if you just rearrange things, you would get 2 cos squared theta minus 1. And if you took the cos squared theta and replaced it with 1 minus sine squared theta, you would get 1 minus 2 sine squared theta. So the cos 2 theta, all 3 of these are the same. However, sometimes one of them is nicer to use than the other. Like for example, if you wanted only sine of theta, then you would use the last one. If you wanted only cos of theta, then you'd use the middle one. If you needed both cos and sine, maybe you wanted to factor a difference of squares, then you would use the first one. So we'll go to our first question here. And when we read this question, given angle theta is in standard position with terminal arm in quadrant 4 and cos theta equals 2/5, comma, that first part up to the comma has happened in so many questions, both in chapter 6 and chapter 7 so far. The beginning of that question has happened over and over and over again. And the strategy that we've used in each of those is I can draw a triangle. I know which quadrant it's in. It says it's in quadrant 4, so it makes sense for me to draw an angle in quadrant 4, go back to my nearest x-axis so that I can label a reference angle for theta. And then cos of theta is 2/5, so that's adjacent over hypotenuse. And you're getting really good at a squared plus b squared equals c squared. And we get square root of 21 for the opposite side. So now in A, if you want to find sine 2 theta, you do not know what theta is. You know what sine of theta is, but you do not know what theta is. The only thing we can do with sine 2 theta is go to our formulas and write out the formula. We know that sine 2 theta is 2 sine theta cos theta, which means if we have our triangle, we know the ratio for cos theta that was given to us in the question. They gave us that cos theta was 2/5. We look at our triangle, sine theta is going to be the square root of 21 over 5, and because it's in quadrant 4, it's going to be negative. And now we just have to say, how do you multiply fractions? This would be like a 2 over 1. Multiply the tops, negative 4, root 21, multiply the bottoms, over 25. In B, they want us to find cos 2 theta, and we have an option of 3 different formulas. And all 3 of those formulas will work, and all 3 of them are perfectly fine to use here. There is one that is slightly better. Not much, but slightly better.
Is it the one that only uses cos?
It's the one that only uses cos. Why would you think that the one that only uses cos would be slightly better?
Because we have the value of cos given to us.
The value of cos was given to us. The other ones use sine, and we didn't get sine wrong, right? We figured out sine, negative root 21 over 5. But can you see yourself accidentally forgetting the negative? Right? Maybe doing a mental math mistake and not getting the square root of 21 right? So there's a possibility, a greater possibility of making a mistake if you use one of the ones with sine. If you don't make a mistake, the other ones are perfectly fine as well. Now, how do we deal with this squared part? Well, this would be 2. I know that cos theta is 2 over 5, so cos squared theta would be 2 over 5 squared minus 1. And now it's just fraction work and order of operations. 2 is 2 over 1. You would square first, so I get 4 over 25 minus, and I'm going to change this 1 to a common denominator of 25 over 25. 8 minus this. So sine of 2 theta is negative 4 root 21 over 25. Cos of 2 theta is negative 17 over 25. Theta was in quadrant 4. What quadrant is 2 theta in?
Still
Three. It's going to be in 3. Why? Because they're both negative. If you use your cast rule, and sine of 2 theta is negative, and cos of 2 theta is negative, that tells us that 2 theta has to be in quadrant 3. Okay, circle question number 9.